So I thought, looking at past papers for OCR, it seems to be that combustion analysis is appearing in order to determine empirical and molecular formula. So I thought we'd do a few examples of those. So here's our first question. Now, need to know it is a hydrocarbon, therefore it contains only hydrogen and carbon. Now it tells me they have burnt, in lots of oxygen, 1.5 grams of my sample. And I have produced 4.4 grams of carbon dioxide and 2.7 grams of water. So the first thing we're going to do is we need to work out the moles of carbon dioxide. So let's give that a go. Moles of CO2. Well, that's going to be just our mass over the molar mass of carbon dioxide, which is 44. And we're also going to work out my moles of H2O, which is going to be 2.70 over the molar mass of water, which is of course 18. So those are the answers there. Now the key thing to note now, if I've got 1 mole of carbon dioxide, for every 1 carbon dioxide there's only 1 carbon atom in there. So if I've got 1 mole of carbon dioxide, I've got 1 mole of carbon atoms in there. So equally, if I've got 0.1 mole of carbon dioxide, I've got 0.1 mole of carbon atoms. So that equals moles of carbon. However, for water, for every 1 H2O, I've got 2 hydrogen atoms in there. And therefore my moles of hydrogen is going to be double my answer. Is going to be 2 times 0.150, which is going to equal 0.300 moles. So for this one, we don't actually need to know the mass, so we can now do a quick check, because I now know my molar ratio of carbon to hydrogen, which is 0.1 to 0.3. Therefore, at that point, to do all of this, you would divide by the smallest one, which is 0.1. So your ratio of carbon to hydrogen is CH3, and that's my empirical formula. So this example is quite similar to the last one. So hopefully try and give this one a go. So just pause the video and then check your answer. Right, so let's do this. Let's work out moles of CO2, and that's going to equal 0.845 divided by 44, and again my moles of water, which is going to be 0.173 divided by 18. Now you remember from the previous one, I need to multiply this guy by 2 to get the moles of hydrogen atoms. So moles of H is going to equal 0.0192. Then you just put your straightforward carbon to hydrogen ratio. I've got 0.0192 for carbon, or 0.0192 for hydrogen. So the molecular formula, the empirical formula is CH. Right, so this one's slightly more complicated, so I will need to use my massive sample here. So they told me how much carbon dioxide and water are produced, but it's told me also the compound contains oxygen. So I have to be a little bit more careful here. So the first thing I've worked out is my moles of carbon dioxide and my moles of water, and then times this number by 2 to find my moles of hydrogen. So that's all fine and dandy, but I need to remember I've also got oxygen in there. So how can I work that out? Well, I know what my overall sample is, weighs, which is here. If I know my moles of carbon, which is this number here, and my moles of hydrogen there, I know my mass of carbon in the sample. So mass of carbon is going to equal my moles of carbon times by 12, which is the molar mass of carbon, and my mass of hydrogen is going to equal my moles times by 1, which is the molar mass of hydrogen. So if we do that calculation, we get that to be 0.0999 grams, and this of course is going to be the same number. So I now know I can work out my mass of oxygen, which is going to be 0.2500 minus my mass of carbon minus my mass of hydrogen. And that comes to 0.1334 grams. So I now need to put all this together to work out my empirical formula. Now I know that my mass of oxygen, I can work out my moles of oxygen, which is going to equal 0.1334 divided by my molar mass of oxygen, which is 16. So let's do that. And that comes to 8.339 times 10 to the minus 3. Okay, let's bung this all together now then. So I've popped my moles underneath the relevant element. So you can see my smallest number there is 8.327 times 10 to the minus 3. So we're going to divide each of those by that number, like so. And if you do that, you get 1 to 2 to 1. So the empirical formula is CH2O. Okay, so again, they've told me it's an empirical form of a compound. And I've got carbon dioxide and water being produced, but it could contain oxygen. Don't know, so I'm gonna have to figure out whether it contains oxygen or not. And then they want me also to find the molecular formula as well. So let's first of all work out the mass of carbon that I've got. 5.841 times 10 to the minus 3 times by 12. And my mass of hydrogen is of course going to equal the same as my moles. So let's do that calculation. And I make that 0.0701 grams. Okay, good. So let's work out my mass of oxygen that I've got. So mass of oxygen is going to equal my mass of the compound minus my mass of carbon minus my mass of hydrogen. That should be 10 to the minus 3. Let's just correct that. Minus 3. So let's do that. And I make my mass of oxygen to be 0.0310 grams. So again, I can now work out my moles of oxygen as being 0.0310 over 16. So let's do that, and that gives me 1.94 times 10 to the minus 3. So I've transferred the moles that I worked out from the previous slide and just put them under the element like I did earlier. And now I'm going to divide by the smallest one, which is going to be the moles of oxygen. And if I do that, that's obviously going to become 1, that is 3, and that is 2. So my empirical formula is C3H2O. So I now need to work out the molecular formula. So if I add up the mass of that, that comes to 55. They've told me the molar mass is about 108, so it would appear that if I times that by 2, I'm obviously going to get to 110, so that would kind of make sense. So it's going to be C6H4O2. Right, so again, we're going to work out the molecular formula for this molecule. So I've done the same as we've done previously. I found my moles of carbon dioxide, my moles of water, realised moles of water, I've got to double it for the moles of hydrogen to give me that number. And then same as before, I'm now going to find my mass of carbon and my mass of hydrogen. Okay, so I've now worked out my mass of carbon and my mass of hydrogen by times my moles of carbon by 12, and my mass of hydrogen is obviously the same as the moles of hydrogen because the relative atomic mass of hydrogen is 1. So now I just need to work out my mass of oxygen, which is going to be the mass of the sample minus the mass of carbon minus the mass of hydrogen. And that comes to 0.2486. And then finally the moles of oxygen is going to be, let's do that, moles is going to be my mass divided by 16. So let's just try and fit that in, and that's going to be 0.0155. So for this one we will divide by the smallest one. So the smallest one is going to be my oxygen. So you'll notice I get slightly odd numbers. Now you cannot round these up or down. You know, 3.65 you cannot round up to 4 or round down to 3. So you've got to get rid of these odd numbers, and the way you do that, if it ends with a 3 or a 6, you times everything by 3. So let's do that. If I times a carbon by 3, I get 10.95. So I'll write that down. 4.66 by 3 is going to be 13.98. And that will obviously be 3. Now these you can round up, so obviously that's going to become 11, that will be 14, and that will be 3. So my empirical formula is C11H14O3. Now if I add all of those up, that comes to 194 for my molar mass, but you notice that it's told me in the question it comes to 388. So I have to times that by 2. So my molecular formula is C22H28O6.